Guys, welcome to 100 Days of Machine Learning project. Today video I am build the currency exchange rate prediction. Okay, you already know the currency exchange for the America and Australia and most variants of the exchange rating of currency exchange rate. This is the live prediction already. The just the Google. Go to check the more detail. Already you have the more information for the Google. But how to build the currency exchange rate prediction in this section? Now I am build the model. Okay, and I'm using same libraries. And this is pandas and matplotlib and same. This is my data. Please see my data. This is my data, and this is see the most of countries have this country. Lot of countries is have this is currency or value and at which date. Okay, this see the how many countries there. See, it's a lot of countries there. Okay, value count. See the most lot of countries. I predict the only one country. I filter that value of the only one country. I am Australian dollar. Okay, I am Australian dollar. I am currency exchange rate prediction. Okay, now I split the only one. Okay, Australian dollar. Okay, yeah, this one I split the Australian dollar. Okay, yeah, this one. Okay. Yeah, this is my Australian dollar. Okay, only Australian dollar I'm predict the value. Okay, I'm save one variable. Okay, see my data, and I'm convert the date column. Okay, this is object. Go to check my info. I already know. See, expand yeah, see the date column is object and convert the time series. Okay, df dot date dot no, nd dot rotate type. Okay, date dot which column, date column. Okay, just see that convert the my time and date column. Okay, save the same variable, save. Yeah, now go to check info. See, I'm convert the time series. Okay, yeah, then I will be finish. Okay, I'm mainly using the model in ARIMA. ARIMA. Most of the person is asking the very difficult the understanding in ARIMA model. Okay, I am explained very easy how to using the ARIMA model. Okay, and ARIMA, I don't know, but I will explain the each and every how to split, how to p value, how to q value, how to d value, or everything I explained the and this currency exchange prediction rate. I am using that modeling using ARIMA. Explain the ARIMA. Okay, this is ARIMA. Okay, AR means auto regression. Okay, ARIMA is AR is auto regression. Okay, this another one is I is integrated. Okay, the shifted value. Okay, I explain that after. Okay, and MA is moving average. Okay, this AR denoted the value of the p value. Okay, and moving and the integrated value is d in differencing. Okay, and moving average value is q. P or D or Q, three value you have to identify to apply the ARIMA model to finish your model. Okay, yeah, we'll be start the each and every value step by step. Okay, yeah, now will be start my read my data, now finish. Okay, now we plot the data. Okay, I split the only and Australia dollar and yeah, Australia dollar. Okay, Australia dollar. Yeah, my df column, my df data. Okay, now you split only and value. Okay, and date. Okay, date and value, I split that. Mm, yeah, I save the same is my df, I save the df. Okay, yeah, now if we plot the value, I have the indexing that, set index and date column. Yeah, yeah, okay, and plot the value df dot plot. This is my value. Okay, yeah, this is year or month, this is my value. Yeah, this is my data. Okay, this is my look like that, this is my data. Now I am you using the ARIMA model. You go to the ARIMA model first, you have to time series, you first check the seasonality. Okay, the very important point for the seasonality. Seasonality means the mean or standard deviation and variance is also constant. This is the seasonality. Okay, your data seasonality, your prediction value is very accuracy, so no noise and no residual. Okay, this is called you want to check the seasonality. I'm helping for the model, I'm using decupolar test. Okay, decupolar test. Okay, this is import the model or the decupolar states model. Okay, the using for your data or seasonality or non seasonality, using that model. Okay, this is some import the decupolar test. Okay, I'm using one variable, have to decupolar. Okay, yeah, my data is df. Okay, my data. Okay, this is values, value. I got to see my data. No, I know that. Okay, df dot head one. Yeah, see, and date column, this is my value column, my prediction value. Okay, the values, value column, this is I'm using that. Okay, I'm check the stationary or not stationary, I'm checking value. Okay, and auto log a I see, and out pd dot series. This is variable or m, extract the value or the 4, 0, 4, the 4 value, I'm extract that, and index my first test the statistics. Okay, another one is p value. You know p value, go to Google or check. Maybe tomorrow I will upload the video of the p value. What is p value? Okay, you studied the hypothesis testing, you definitely you know p value. Okay, and another one logs. How the logs used, number of observation used. Here I finish. Now will be I put the for loop key or value and my variable m, and for value and data items. Okay, now I am using out and critical value. Percentage key now equal to value. Here now we print my out value. Yeah, run the code. I be expecting some mistake here. See, what is that? Maybe some mistakes. Yeah, unexpected. Yeah, value. Yeah, yeah. Now will be finished. Go to check the value. This is p value. Okay, you are less than 0.05. You got acceptable. Okay, your value is stationary. Okay, and that now is 0.9. This is not stationary. Okay, you convert the you exchange or transform your data stationary. Okay, now my your p value is 0.9. Okay, your p value is 0.005, less than 0.05. Your value, your data is stationary. Now 0.9. Okay, now is not stationary. You convert or transform your data and stationary 0.05 less than. Okay, now after test or transform your data, your p-value is less or not, every transform have to check decoupler test, finish your transform or stationary, after go to apply the model. Okay, now your data is not stationary, 0.9. Okay, less than 0.05 your data is stationary. Now p value is high, is not stationary. Okay, now we'll be going to some transform, apply Lax transform, exponential, the many of transform is how. Now I one by one apply and check the p value, apply the transform, check the p value. Okay, now step by step and transform your data or the stationary. Okay, now it's not stationary, you can now apply this transform. Okay, okay, I am using the logs transform first. Okay, np.log your df. Okay, yeah, I am using and save the log. Okay, save the log. Now I'm check rolling our data. Okay, rolling, and you know that Windows function. Yeah, Windows is 12-month rolling dot mean. Okay, yeah, also and rolling window and one dot standard deviation. Okay, save the log of save log mean, also save log std. Okay, yeah, now the finish my rolling, my shifted my value at the roll. Okay, is check. Huh? And I'll be plot the value. Okay, you know that I'm asking or mean or standard deviation is constant. your data is stationary. Yeah, that will do the rolling and the mean or standard deviation. Okay, now I am log minus log mean. Okay, my transform value, my log value, I am also so rolling the value of the mean already calculation, that will be minus the value. Okay, this is my data. Okay, yeah, I am save the one variable log mean scale. Yeah, I'll be finished. And apply the decoupler test. Go to check our data is stationary or not stationary. Okay, yeah, I'm save and drop now some null value. Yeah, save that variable. Yeah, now I now I am check my data is stationary or not stationary. Okay, I'm using the logs transform. Okay, okay, and this is copy the all the decoupler test function. Okay, say and copy and paste that. I'm using this one. I check. Okay, my transform log transform value and check my value stationary not stationary. Copy that value. Yeah, I got to run the code. Yeah, see my p-value is 0.02. Okay, go to check the before p-value is 0.9. Okay, it's better improvement. My p-value is transform the not stationary before, now little bit stationary my data. So 0 point and 02. Okay, yeah, now go to the another transform. So most of the transform is how I'm using the log transform. Another one is the exponential transform also. Okay, I'm using the exponential transform using log dot ew exponential. Yeah, done. Yeah, this of l my volume is 12, 12, and the mean period in periods 0, just equal to 2, 2 dot mean. Okay, yeah, finish my save the variable exponential. Okay, now I'm check or log and minus and the same exponential. Okay, minus that. Okay, now go to log, save the variable log expo. Okay, simple concept. I exponential I transform the exponential after minus the log value. Okay, I'm already transform the log, this variable log. Okay, then another one is I transform the exponential value. That value is simply the minus that. Okay, store the variable log expo. Now I go to check decoupler test. Okay, decoupler test how to implement my transform or stationary or not stationary. Okay, copy the value, copy the code and paste that to the log expo. Okay, log expo. Go to check. See my p-value is a 0.4 is a high. Okay, this is not stationary. Okay, how to improve the another shifting. Okay, now I am transform the data and I'm using the two transform, one exponential and log transform. Yeah, it's not achieve the my value is stationary. Okay, this is 0.9, the exponential is 0.04. I am already asking 0.05, the less than 0.05. Okay, your values are stationary, your data is now value is 0.4 is not stationary. Okay, this is not using for ARIMA model, your accuracy is very less, not good prediction. Okay, now to I am another shifting, I'm using the shift. Okay, and the log shift. already have the transform the data. Okay, I'm using the shift. Okay, minus same log dot shift. Okay, shift is zero shift, only shift. Okay, this is my this value 0. Okay, another one shifted value. Okay, I'll just save the value, log shift. Okay, now you go to check or decoupler test. Now how to my improve the stationary or not stationary. This I save the copy or paste the decoupler function. This is log a shifted value, the copy or paste. Okay, run the code. You have null value on not acceptable. Go to null value, drop no shift out, drop no, and save the variable. Yeah, now will be run the code or decoupler. Yeah, see my p value or minus 15. Okay, that is good improvement. My data transform and my value is stationary. Okay, now will be finish or my using the I'm using the log sheet, using my value is stationary. I am achieve the stationary, one is finish. Okay, this I am stationary is one is a different thing, and I'm already asking the ARIMA model as I is a interaction. Yeah, this is a different thing. Okay, so I value now is a finish, I value is a 0. Okay, this is I'm shifting using the only shift or shifting, and this one is a log transform using on the log shifted as a 0 and check the p value, and p value is 0.05, very less value my p value. This is my data is stationary. Yeah, this is my data, this data is my using the model. Okay, now will be finish or shifting or I value integrated value. Okay, shifting differencing value now is a finish. Now I am go to check the and the p value and the q value. Okay, I am using the p value or q value identifying. I using the plotting or the ACF or a PCF. Okay, auto correlated and the partial auto correlated factor. Okay, so though I am I am using the check the p value or q value. Okay, import some model or the plotting or the ACF and the PCF. Okay, so PSA plots, import plot ACF and plot partial auto correlation factor. Yeah, I import the model. Yeah, now will be I am plot the uh, my data. Okay, my data I'm already converting stationary. Okay, that value is log shift. This is my data, I am using this data. Okay, I am using this data identifying the p value or q value. Okay, that is another of the auto correlation and moving average. Okay, okay, now we plot the value. Okay, and also using the states model ms or API. Okay, and the plot the value or log shift. Okay, the graphics ds is plot and also the graphics. Yeah, go to plot my data ACF equals, and this another value suddenly is a less. Yeah, this inside this shadow inside the value. Okay, this one's avoid that 0, this one is 1, so my your shifted value is 1. Okay, ACF value is q equal to 1. Okay, this shifting the 0, another 1 is suddenly low. Okay, this is your p value, so q value is note that q value is 1. Okay, yeah, now will be check another one and p value and pc. Okay, pcf, copy the code or same and change them this one. Okay, now we plot the value, check, although also same this one, the suddenly another value use less. Okay, this shadow value, very well, another value use q value equal to 1, p equal to 1, or q equal to 1. Okay, q1 also p value, this one p. Okay, this value is p value is 1 also, or q value is 1 also. Okay, how to see the p value is, see the values, or this one value is 0, this is 1, is 2 or 3 4, this like that. Okay, one first value is 0, this is very peak. Okay, another value suddenly less. Okay, suddenly less, the inside the your shadow, this shadow, this correlation shadow, this shadow. Okay, your shifted value is 1, this is your p value, your q value is 1. After the see the p value also is shifted 0 or 1. Okay, also your p or q value equal to 1 1. Okay, p value also 1 and q value also 1. Your I value is I already asking your stationary data shifted or 0 shift. Okay, equal to 0. Okay, you are shifted the 0, this one. Yeah, right. Next one is, yeah, this one I shifted the 0. Okay, shifted the 0, you achieve the stationary. Okay, your difference in value equal to d value 0, p value I'm already asking ac of your value is q value also 1, or p value also 1. Your differencing value equal to 0. Difference value, how to check, your shifted the value, you achieve the stationary. Okay, this is your three value you have, or p or q or d, three value all you have, you build the model. Okay, yeah, I'll build, go to build the model. Now I am import the ARIMA model. Okay, sam dot tsa ARIMA, okay, yeah, like this ARIMA, this one. Okay, yeah, you go to data is log shift. Yeah, you are achieve the stationary data, this is log shift. Okay, that data you have to apply the ARIMA model shift. Okay, yeah, you are value the order, p value, q value, difference in value 1 1 0. Okay, p dq. Okay, this value is finished. Now will be model, I'm save that. Okay, log shift. Yeah, now we finish. Okay, now we fit the model, uh, result. Okay, model dot fit. Okay, model is fit, then I'll be finish, my model is fit. Okay, now will be calculate my performing my data and error. Okay, and my result dot let value, filtered value minus log shift. Okay, my variable log shift, my column value. Okay, this is my data and prediction value, and my value sum the value. Okay, yeah, sum. This my error is very less, 0.00000170. My model is very good perform, my error is very less. Okay, our model is very good. And I will be go to predict the model. Okay, this is fit result. Okay, go to predict, and this one dot predict. Okay, I predict 10 value. Okay, it is starting 1 and end also 10. Okay, I am predict the only 10 value. I save the predict. Okay, save the prediction value. Okay, save one variable, this is my prediction value. Okay, at the same, and my log shift logs it and extract the my 10 value. Okay, this value I am predicted. Okay, this value I am predicted. Okay, this value I am predicted only 10 value start 1 to 10 value prediction. I'm also original value, this is extracting. Okay, so the original value, so the very original value now will be plot original and the predictions how to look like. Okay, yeah, your plot first I got the original dot plot. This is my original data, this is my original. Okay, original of the 10 value, first 10 value. Okay, now we predict value, how that. Okay, how to predict my value of this. PRD dot plot. Okay, and color red, see red color my prediction. Yeah, see, and this is blue line my original value and the red line my prediction value. Okay, nice good my model. Okay, that's good prediction. Okay, not less error. Yeah, good. You go to check or improve your model. Okay, you read the paper or my description page, my sender. Okay, you go to improve your model, improve change or a lot of using transform. Okay, you get a more accuracy also you have. Okay, yeah, now we'll predict the another after. Okay, and result of predict. First you got to check a log original value of the log shift dot shape. Okay, this is my shape of value and 112. Okay, 112. I'm after predicted 100 after 10 value I'm predicted. Okay, my starting value 112. Okay, my end value I'm 10 value I have to predict 122. Okay, we will predict, yeah, this value I am after. Okay, after predicted value this. Okay, okay, that will finish. Thank you for your watching and share my this page. You go to read and play with the code, you improve your knowledge or improve your model train and very using the efficiency. Okay, go to check or read or play the code. Okay, and thank you for watching and thank you so much.